If you're a fan of science history, then you need to know how our understanding of air transformed thanks to a single glass tube and a daring question. For centuries, air was seen as nothing, a weightless void. But then, a storm, a wind, a collapsing pump. These everyday wonders sparked a bigger question. Could the invisible actually push back? Enter Evangelista Torricelli. With a slender glass tube filled with mercury, he revealed the truth. Air has weight, and that weight presses down on us all. The barometer was born, turning the unseen into something we could measure. Suddenly, air was no longer a phantom. It became data, charted and studied, guiding everything from weather forecasts to flight. The barometer's journey is a testament to curiosity, and how one bold idea can turn the invisible into knowledge. And now, a special message for all the flowers out there. Don't forget to subscribe to the For Science Salah Lotfy channel and keep blooming with knowledge.
Welcome to For Science Salah Lotfy channel, where global scientific research becomes clear and accessible.
هنا نحول الأبحاث العلمية العالمية إلى معرفة مبسطة مترجمة لك بلغتك.
Ici, la science est expliquée et traduite pour tous.
Ciencia clara, accesible y disponible en varios idiomas.
Wissenschaft, verständlich und mehrsprachig für jeden.
قناة For Science Salah Lotfy channel. العلم للجميع وبجميع اللغات. تابعنا لاكتشاف المزيد.
I'm sure you've heard the news, but have you ever stopped to think about the air around you? It's something we all take for granted, yet it's absolutely essential to our lives. Every headline, every conversation, every moment you spend listening to the world, air is there, quietly making it all possible. Imagine a world without it. Hard, isn't it? That's because air is so fundamental we barely notice it until we start to wonder about its mysteries. Air is everywhere, right? It fills every space, from the tallest skyscraper to the smallest playground. We breathe it in, we feel it on our skin, and it shapes the world in ways we rarely notice. But what if I told you, for most of human history, people barely thought it existed at all? The very thing that keeps us alive was once invisible not just to our eyes but to our understanding. It's almost as if air was hiding in plain sight, waiting for someone to ask the right questions. Ancient thinkers believed only what could be seen mattered. To them, the world was made of earth, water, and fire, things you could touch, see, or feel. Wind moved trees, storms stirred seas, yet no one understood how. The invisible force that shaped weather, carried scents, and cooled the skin was a complete enigma. Some even thought air was just empty space, a void between objects. The idea that it could be something real, something with weight and power, was almost unthinkable. The big question: how do you study something you can't see or touch? This mystery challenged science for centuries. It took brilliant minds, clever experiments, and a lot of curiosity to finally reveal air's secrets. Scientists had to invent new tools and ways of thinking just to prove that air was real, that it had weight, and that it could be measured. Their discoveries changed everything, from how we understand weather, to how we breathe, to how we explore the universe. So next time you take a breath, remember, air went from nothing to everything. It's the invisible hero of our daily lives, connecting us all in ways we're only beginning to understand. And hey, if you're as curious as the scientists who solved the mystery of air, don't forget to ask the flowers and your friends to subscribe to For Science Salah Lotfy channel. There's a whole world of invisible wonders waiting to be discovered.
In the early 1600s, engineers ran into a strange problem. They could build powerful water pumps, but the water just stopped. No matter how hard they tried, it wouldn't rise above a certain height, about 10 meters. This baffled everyone. Why was the water refusing to cooperate? Some people thought nature simply hated emptiness, so water filled the space to prevent a vacuum. Others pointed fingers at faulty machines or lazy workers. But every explanation hit a brick wall. Philosophy, with all its clever words, couldn't explain what was right in front of their eyes. Here's the wild part. Nobody knew how high water go because no one was actually measuring it. They were guessing, like trying to solve a puzzle with half the pieces missing. This confusion set the stage for something huge, the rise of real science. See, before measurement, all those theories were just stories. Only by actually measuring the height and testing the pumps could people move past the myths and get to the truth. This is the moment science realized it needed more than good ideas. It needed evidence. So next time you see a pump or a fountain, think about it. For centuries, people stared at rising water and tried to reason their way through the mystery. But it wasn't until experiment and measurement took over that the real answers started to flow. Sometimes the most important step in solving a mystery is grabbing a ruler.
If you're a science fan, you absolutely need to know about one of the most groundbreaking experiments in history. Torricelli changed our understanding of the world forever, using nothing more than a simple glass tube and some mercury. Here's the twist. He uncovered something invisible, yet incredibly powerful, that surrounds us every moment. Back in the 1600s, Evangelista Torricelli, a brilliant student of Galileo, set out to solve a mystery that puzzled scientists for centuries. He carefully filled a long glass tube with heavy, shimmering mercury, then quickly flipped it upside down into a dish of more mercury. To his amazement, the mercury inside the tube dropped to exactly 76 centimeters, leaving a mysterious empty space at the top, a true vacuum. Torricelli realized it wasn't magic or superstition holding up the mercury, but the actual weight of the air itself, pressing down on the mercury in the dish and supporting the column in the tube. That's how Torricelli proved that air has real, measurable pressure, and in doing so, he made science history, opening the door to modern meteorology and physics.
Imagine a world where we didn't know that the very air around us could actually push down on things. For most of human history, people simply took the atmosphere for granted. They saw the wind blow, felt storms roll in, but never really questioned what air was made of, or if it had any weight at all. The idea that something invisible could exert force was almost unthinkable. People believed that air was just empty space, a void between us and the heavens. But in 1643, a brilliant Italian scientist named Evangelista Torricelli changed everything. He filled a long glass tube with mercury, sealed one end, and flipped it upside down into a dish of mercury. To everyone's amazement, some mercury stayed suspended in the tube, refusing to fall out. What was holding it up? It wasn't magic. It was the pressure of the air above the dish, pushing down and supporting the mercury column. This was the first time anyone had concrete proof that air had weight and could exert pressure. For the first time in history, scientists could actually measure the atmosphere as if it were a tangible physical substance, just like water or metal. Torricelli's mercury barometer became a revolutionary tool, allowing researchers to track changes in air pressure and predict weather patterns. Suddenly, the invisible world of the atmosphere became something you could study, record, and understand. This single experiment didn't just reveal the secrets of air pressure, it sparked the birth of fluid mechanics, a whole new branch of science. Air was no longer just an empty void. It became a material to be tested, measured, and experimented with in the lab. Torricelli's work inspired generations of scientists to explore the mysteries of gases, liquids, and the forces that move them. And hey, even flowers owe their gentle sway in the breeze to the science Torricelli helped uncover. The next time you feel the wind or watch clouds drift by, remember, it all started with a simple tube of mercury. If you love discovering the hidden forces of nature, hit subscribe for more, with For Science Salah Lotfy. Have you ever wondered why those enormous glass tubes, once a staple in weather stations, have all but disappeared from modern meteorology? For centuries, the mercury barometer was the gold standard for measuring atmospheric pressure. These devices, with their elegant glass columns filled with shimmering mercury, were not only scientific instruments but also works of art, often displayed with pride in observatories and laboratories around the world. However, as beautiful as they were, mercury barometers came with significant drawbacks. Mercury, while effective, is highly toxic, posing serious health risks if the glass tube broke or leaked. The barometers themselves were large, heavy, and fragile, making them difficult to transport and maintain. Handling them required extreme caution, and even a small accident could result in a dangerous spill. As scientific needs grew and technology advanced, inventors began searching for safer, more practical alternatives. This quest led to the invention of the aneroid barometer, a revolutionary device that uses a sealed, flexible metal capsule to measure air pressure. Instead of relying on liquid mercury, the aneroid barometer detects changes in atmospheric pressure by the expansion and contraction of this capsule, which then moves a needle on a dial. With no liquid to spill and no glass to shatter, the aneroid barometer quickly became the preferred choice for scientists, sailors, and weather enthusiasts alike. Its compact design made it easy to use in the field and in homes. Thanks to clever engineering, modern barometers now measure air pressure with intricate moving parts instead of hazardous mercury. The science remains the same, but the process is safer, more reliable, and far less dramatic, making weather prediction accessible to everyone.
If you're tired of guessing whether you'll need an umbrella or sunglasses tomorrow, there's a better way to predict the weather. Just check the air pressure. For centuries, people relied on looking at the sky and making wild guesses. But now, thanks to science, we have tools that can give us real clues about what's coming. Air pressure is one of the most important signals nature gives us about changing weather. Imagine you're climbing a mountain. As you go higher and higher, you might notice it gets harder to breathe. That's because the air pressure is dropping. The higher you go, the less air there is pressing down on you. It's a bit like opening a soda bottle. When you twist the cap, the pressure inside drops, and you hear that familiar fizz. The same thing happens in our atmosphere, just on a much bigger scale. Scientists were fascinated by these changes. They invented barometers, special instruments that measure air pressure, to help them understand and predict the weather. With a barometer, you can actually see the pressure rising or falling, giving you a sneak peek at what the sky might do next. These tools have been used for hundreds of years, from old glass tubes filled with mercury to modern digital sensors. When the air pressure starts to fall, it usually means a storm is on the way. Clouds gather, winds pick up, and rain might be coming. On the other hand, when the pressure rises, it's a sign that clear, sunny weather is ahead. Meteorologists watch these changes closely to make accurate forecasts, helping us plan our days and stay safe. So, the next time you check the weather on your phone or see a meteorologist on TV, remember that it's all possible because of the science of air pressure and altitude. These discoveries have made our lives easier and more predictable. And if you love learning about the wonders of science, don't forget to subscribe to the For Science Salah Lotfy channel. Maybe even ask the flowers to join in.
Barometers aren't just antiques. They're hiding in your phone right now. For centuries, barometers were elegant, mechanical devices, often found in the homes of weather enthusiasts or hanging on the walls of ships. These classic instruments used mercury or aneroid mechanisms to measure atmospheric pressure, helping people predict storms or fair weather. But today, the barometer has evolved far beyond its glass and brass origins. The journey from those early handcrafted devices to the digital sensors in our pockets is a story of scientific ingenuity and technological progress. What was once a specialized tool for sailors and meteorologists is now a silent, ever-present companion in our daily lives, quietly working behind the scenes. Modern barometers use tiny, sophisticated pressure sensors, so small they can fit inside your smartphone or smartwatch. These micro-electromechanical systems, or MEMS, are marvels of engineering, built with microscopic parts that respond to the slightest changes in air pressure. Thanks to advances in miniaturization, these sensors are not only more accurate, but also more affordable and energy efficient, making them perfect for everyday devices. As air pushes against these sensors, their flexible membranes bend and flex. Imagine pressing your finger into a trampoline and watching it dip. This movement is incredibly subtle, but it's enough to trigger a measurable response. Even the tiniest shift in air pressure, invisible to our senses, is captured and recorded by these sensitive membranes, allowing for precise and continuous monitoring. That tiny bend is instantly converted into an electrical signal, which is then processed by the device's circuitry. The signal is translated into digital data, allowing your phone or device to interpret and display real-time atmospheric pressure readings. This seamless process happens in milliseconds, making it possible for apps to deliver up-to-the-minute weather updates or altitude information. Now, pressure isn't just measured, it's computed, shared, and analyzed everywhere, all the time. From your pocket to weather stations, airplanes, and even satellites orbiting Earth. Digital barometers help us understand our world in ways those old antiques never could. The evolution of the barometer has truly transformed how we interact with and interpret the invisible forces of our atmosphere. And now, a special message for all the flowers out there. Yes, you, the bright and blooming ones. If you want to keep growing your knowledge and soaking up the sunshine of science, don't forget to subscribe to the For Science to Salah Lotfy channel. Hit that button and let's blossom together on this scientific adventure.
I'm sure you've heard the news. Sometimes barometers give different readings. You might have noticed this yourself if you've ever compared two barometers in the same room, or checked the pressure on your phone and then looked at an old-school analog barometer. The numbers don't always match up, and that can be confusing. It's not just a quirk of the devices. There's real science behind it. Why is that? Why do two instruments designed to measure the same thing sometimes disagree? Is one broken? Or is there something else going on? This is a question that has puzzled scientists and weather enthusiasts for centuries. The answer lies in the details of how barometers work and, more importantly, how they are set up before use. It all comes down to calibration. Calibration is the process of fine-tuning an instrument so that its readings match a known standard value. For barometers, this usually means adjusting them to read the correct atmospheric pressure at sea level, which is considered the baseline. Without this crucial step, even the most expensive or high-tech barometer can give you numbers that are way off from reality. Calibration ensures that every barometer, no matter where it's made or how it's used, speaks the same scientific language. Without proper calibration, measurements can be way off. Imagine trying to bake a cake with a scale that hasn't been zeroed, or measuring your height with a ruler that starts at the 2-inch mark. The results would be misleading, and you'd never know for sure if your data was accurate. The same goes for barometers. If they aren't calibrated, their readings can't be trusted, and that can have big consequences for weather forecasting, scientific research, and even aviation. Calibration is what makes our data trustworthy. It's the invisible step that turns a simple device into a reliable, scientific instrument. So, the next time you see two barometers with different readings, remember, it's not just about the device, it's about how carefully it's been calibrated. That's the science that keeps our measurements meaningful and our predictions accurate.
If you're a science lover, you need to know how a simple glass tube filled with mercury changed the way we understand our world. Imagine living in a time when the air around us was considered weightless, invisible, and impossible to measure. Then, in the 17th century, a curious Italian scientist named Evangelista Torricelli decided to challenge that idea. He filled a glass tube with mercury, inverted it into a dish, and watched as the mercury level dropped, leaving a mysterious empty space at the top. What was happening? Torricelli realized that the invisible air above us was actually pressing down, holding the mercury in place. This was the birth of the barometer, a tool that would forever change science and our understanding of the atmosphere. Ready to get inspired? Let's dive in. From those early mercury columns, carefully observed by candlelight, to today's sleek digital screens that fit in your pocket, the barometer has evolved in remarkable ways. Early scientists marveled at the way a simple instrument could reveal the secrets of the sky. Over centuries, inventors and engineers refined the barometer, making it safer, more portable, and more accurate. Today, we have digital barometers that can measure air pressure with incredible precision, helping us predict storms, track climate changes, and even monitor our own health. But one thing has always stayed the same. Air, though invisible, always presses on everything around us. Whether you're standing on a mountaintop or at sea level, the weight of the atmosphere is constantly pushing down, shaping our weather and our lives. The barometer lets us see and measure this invisible force, turning the unseen into something we can understand and predict. By measuring that pressure, we unlocked the mysteries of weather, made flight possible, and gained a new way to see our planet. Meteorologists use barometers to forecast storms and sunshine, pilots rely on them to navigate safely through the skies, and scientists use them to study everything from hurricanes to climate change. The barometer is more than just a tool, it's a window into the invisible forces that shape our world. The barometer proves that even what you can't see can be measured, understood, and used to make life better. It reminds us that science is about curiosity, about asking questions, testing ideas, and finding ways to measure the invisible. Every time you check the weather or fly in a plane, you're benefiting from the simple brilliance of the barometer. Curious to learn more about the amazing tools that make science possible? Subscribe to For Science Salah Lotfy and join us as we explore the inventions, experiments, and discoveries that make our world so fascinating. There's always more to uncover, so let's keep exploring together.